Okay, so lymphocyte recirculation and homing, chapter 4 of immunology. What does the USMLE require us to know? We need to know what is the structure of the secondary lymphoid organs, what is the function of the secondary lymphoid organs, where exactly is it that the B cells localize in the peripheral lymphoid organs? Where do the T cells localize in the peripheral lymphoid organs? And what exactly do chemokines do in lymphocyte trafficking? And what do adhesion molecules do in lymphocyte trafficking? Right, so let's get to it. Lymphocytes of the B and T cell lineages that have completed their selection in the bone marrow and the thymus, respectively, are now considered mature naive lymphocytes, ready to begin their role in the surveillance of the body against invaders. Now, these mature but naive lymphocytes will begin the process of recirculation through the body, which is essential for ensuring that the limited number of cells with receptors for a specific antigen is enabled to search for that antigen throughout the body. So, these naive cells will preferentially recirculate through the peripheral secondary lymphoid organs, which are the lymph nodes, they're the spleen, and they're the mucosal associated lymphoid tissue, MALT. And by doing this, they will maximize their chances of encountering a foreign antigen and thus initiate a specific immune response, the adaptive immune system. So what did we learn? We learned that what are basically the peripheral secondary lymphoid organs? And they are the lymph nodes, they are the spleen, and the mucosal associated lymphoid tissue. And what do they do exactly? They're basically sites of foreign antigen exposure. Everybody goes there with their little antigens that they've collected throughout the day to share and boast about, look at what I found. And these lymphocytes are there waiting to see, all right, is this something I want to invest in maybe? Maybe it's like a stock exchange, who knows? Anyway, so lymph nodes are the small nodular aggregates of secondary lymphoid tissue found along the lymphatic channels of the body and are designed to initiate immune responses to tissue-borne antigens. So this is where all the antigen-presenting cells from the tissues only, they collect all these antigen-presenting cells, collect all these little antigens they find all along their tissues, and then they go and hang out at the pub, at the lymph node. And over there, they present these antigens to the lymphocytes. So remember, they come from the tissues only. Well, then each lymph node is surrounded by a fibrous capsule. Now, what I'm going to do is I'm going to go up to the picture. That way, we can see what we're talking about. Okay, so lymph nodes are the small nodular aggregates of secondary lymphoid tissue that is found along, well, we've already done this. So in a nutshell, so lymph nodes, there it is, are small nodular aggregates of secondary lymphoid tissue found along the lymphatic channels of the body and are designed to initiate immune responses to tissue-borne antigens. Each lymph node is surrounded by, there's a fibrous capsule right there. This is the fibrous capsule that is punctured by afferent lymphatics. There is the afferent lymphatic coming in, punctured right there, which bring lymph into the subcapsular sinus. And this is the subcapsular sinus right there. See, this is where it's coming. So subcapsular sinus. Then the fluid percolates through an outer cortex. Here's the outer cortex, comes in here, enters the sinus, the subcapsular sinus, and then it percolates through this outer cortex areas that actually contains aggregates of cells called follicles. Here are all the follicles right there. Okay. The lymph then passes into the inner medulla. Here's the inner medulla. It goes from here, percolates around the follicles, and enters the inner medulla right there. And the medullary sinus. So that part is called the medullary sinus. Basically, it's the same canal, and it is the medullary sinus. So here's the cortical, subcortical sinus there, subcapsular sinus, and here is the inner medullary sinus right there. All of this. Before leaving the node through the hilum, this area is the hilum area, in an efferent lymphatic vessel. These are the efferent lymphatic vessels. Ultimately, the lymph from throughout the body is collected into the thoracic duct, which empties into the vena cava and returns it to the blood, heart, and blood vessels. Okay then. So next, let's look at the spleen. So that's pretty explanatory right there. Okay, let's go over the picture real quick. Germinal centers, this is the follicle, primary follicle, B-cell rich. You see that in the middle, this is the germinal center of the follicle. This outer part is the cortex, followed by the paracortex, then the medulla. This is the capsule. Under there is the subcapsular sinus. When it enters into the medulla area, it's called the medullary sinus. And this is the afferent, and then this is the efferent lymphatic arterial. I think that about covers it. Awesome. So in a nutshell, lymph nodes filter tissue fluids. Outer cortex contains follicles, which are basically B cell areas, and paracortex is the T cell area. And the inner medulla contains macrophages. Now that is important. So what we have here, follicles, B cells, paracortex, T cell, inner medulla, macrophages. So B cells, T cells in these areas, and in here are the macrophages. Great. Okay then, moving on to the spleen. The spleen is the secondary lymphoid organ designed to initiate immune responses to blood-borne antigens, right? The lymph nodes are for tissue-borne antigens. The spleen is for blood-borne antigens. Now, what you have here is a single splenic artery. There's a single splenic artery right there that enters the capsule at the hilum. This is the hilum, this entire area. And it enters the capsule from there. This outer area is the capsule. And branches into arterioles. So once it's in there, it branches into all these little tiny little arterioles, which become surrounded by cuffs of lymphocytes. These little areas, these little light blue areas, these are cuffs of lymphocytes, and we have a name for this, and that is periarteriolar lymphoid sheets, or PALS, periarterial lymphatic sheets. Then around past those, there's this little white area. You see that? That is where you have the lymphoid follicles, which are surrounded by a rim of lymphocytes and macrophages attached nearby. So you have all these lymphoid follicles, these tiny little blue dot thingies. Sometimes you have the big primary follicle, all of these. Well, they are surrounded by lymphocytes and macrophages. So outside you have the lymphocytes and the macrophages. Anyway, so this whole area is called the white pulp. So you have pals, then the white pulp. And then the arterioles will continue on past this area, and eventually they will end up in something called, they'll just, what did they say? They end in vascular sinusoids. So they're just open areas of blood, basically. It's a bag full of blood, basically. Vascular sinusoids, which make up the red pulp. So here comes the artery, turns into arterioles, goes through the pals. Past the pals is the white pulp with vacuoles or follicles, lymphoid follicles that look like vacuoles. Anyway, they have the lymphocytes and macrophages there, and this is called the white pulp area. And past that is the red pulp, right there. So they go there, and then these arterioles just end in there, and there's all this blood all over this area. And eventually, what happens is from here, this blood in the red pulp is collected into the venules, which will collect the blood into the splenic vein, and which will then carry on. Here's the splenic vein, and that will end up and join with the portal circulation, which is also receiving blood from the GI, right? Okay, so let's take a look at this picture. Transverse section of the white pulp. So here we're just cutting right across here, it seems. You see, that's the central arteriole right there. That's the arteriole. Around that, obviously, was what? The PALS, periarterial lymphatic sheath. So that's probably periarterial lymphatic sheath. And we have to know that this is mostly full of T cells, okay? So where were the T cells in the lymph node? The T cells in the lymph node were in the paracortex, right? Here in the spleen, the T cells are in the periarterial lymphatic sheath, okay? So let's go a little bit past there, and this is the white pulp. So obviously, this is the white pulp. But notice that if you were to cut here, for instance, right there, right? Or actually, yeah, maybe right there. You would have the PALS, periarterial lymphatic sheath, but look at this. There's a little germinal center there. We're cutting it here, for instance, right? So that is the germinal center. And beyond that is the B cell corona. Okay, don't quite understand what that means. So you have this marginal sinus around, it's kind of difficult to visualize when it's not 3D, but it's like, you have this in a two-way cut section in a way, but on top of it, there's also, this whole area is also has the sinus, blood-covered area. So that is what's demonstrated with this, you see. So you go deeper into, so this out area, wait, I am getting this wrong. Okay, so we have the red pulp, right? Inside is the marginal zone. Okay, inside that you have marginal sinus, and inside that you have the B cell corona. There we go. Oh, look at that, there's a picture here. This is probably the arteriole. This is the feeding, so this is the arteriole coming through. Longitudinal and transverse section. I'm having trouble understanding this. Okay, so you have the arteriole, marginal sinus. Where's the red pulp? Right there. Okay. So, but I don't see it going anywhere. So, okay, I understand that you are getting into an artery. Obviously, this would obviously be the periarterial lymphatic sheath, right? Around the periarterial lymphatic sheath, you would have all these germinal centers, right? That I understand because of that. And Then past that, what is this? This is considered the marginal zone. The white area is marginal zone. And this is the marginal sinus. Don't quite understand this, but okay. And then this will just empty out into some kind of sinus, which is called the red pulp. Okay then. All right, moving on. So I need to know that where's the red pulp is right there. I need to know that the T cells are found in the periarterial lymphatic sheath. I need to know the B cells are found in the germinal center, past the germinal center, around the B cell. So there's a germinal center around that is the B cell corona. I need to know that. And germinal center is surrounded by the B cells. And yeah, that's the most important thing here. Okay. Moving on to the next section, which would be about the adhesion molecules. All right. So for this, I need paper and a pencil. So you have all these naive lymphocytes, right? You have these cells, lymphocytes. They enter the lymph node from the blood and through high endothelial. Okay, what? So naive lymphocytes enter the lymph nodes from the blood through high endothelial venules. Okay, so you have lymphocytes, so B cells and T cells, right? They are going to enter lymph nodes. They're going to come from the blood. So blood is entering the lymph nodes with the B and T cells. And this is called high endothelial venules. I think what we're talking about here is this area right there. Why don't we just call it afferent lymphatic? Well, no, but we're not talking about that, right? From blood. We're talking about naive lymphocytes enter the lymph nodes from the blood, not tissues or lymph, from the blood. So we're talking about the splenic artery and pass the splenic into the arterial and from arterial to the central arterioles and breaking it down further, I think. Okay. Through high endothelial venules. Venules. It's so they become really thin like that, maybe. That's probably it. This migration involves a multi-step sequence of interactions between lymphocyte and adhesion molecules on the endothelium. Okay. So blood's coming, goes through the pals and whatever, but anyway, you end up with all these little tiny little venules, and these are really high endothelial venules right there. But how does it enter from? But they're saying lymphocytes enter the lymph nodes. You're saying naive lymphocytes enter the lymph nodes from the blood, not the oh, I see. We're not going to discuss completely different. Okay, so you have two things happening. I really need to get another picture up here somehow. Maybe I could, I don't know. Okay, here's what we'll do. We'll copy this and post it so we can see the picture at the same time. All right. Let's take a look at this picture. And so this is where the lymph is coming in, right? And this is where the lymph is leaving. Lymph, not blood, lymph. Okay. But we're talking about lymphocytes. The lymphocytes entered the thymus or the bone marrow, and from the bone marrow, they entered the blood. And from the thymus, they entered the blood, not the lymph. See? So what happens is, oops. So what happens here is that you have a whole bunch of things going on. So you have the bone marrow which give rise to your B cells, right? And those B cells will enter blood circulation. Then at the same time, you have bone marrow, which gives rise to, well, immature, well, we'll just say T cells. T cells, which are naive, and they will further go to specialize and go to the thymus, which will also end up in blood. And on the other hand, you have lymph, right, which comes from tissues. Tissues gives rise to lymph, and lymph will go into lymphatic vessels, lymph vessels, and they will enter afferent lymphatic vessels to enter the lymph node. Okay, so we have established that. Now what happens? Now, well, we're talking about naive lymphocytes, right? So we're talking right here. These naive lymphocytes right there. These are the naive lymphocytes that have just decided to enter blood. Well, now these naive lymphocytes will enter these lymph nodes right there. How will they do that? From the blood. So blood with naive lymphocytes enter the lymph nodes through high endothelial venules. That makes sense now. So this migration from blood to high endothelial venules involves a multi-step sequence of interaction between the lymphocyte and adhesion molecules on the endothelium. So we have to know what is special about this lymphocyte, what is special about these endothelial venules. So multi-step sequence, that's what we need to know. What is that? Between lymphocytes and adhesion molecules on the endothelium. The initial low affinity. So first thing you have is you have an initial low affinity interaction, right? What is that exactly? Is mediated by homing receptors called L-selectins present on the lymphocyte. So this lymphocyte, naive lymphocyte right there, has L-selectins present on the lymphocytes, which bind to addressins present on the HEVs. So these HEVs have addressins, kind of like addressins. But this is just so they will bind to these L-selectins will initially bind these addressins in an initial low affinity interaction, right? So that's what happens. Okay, so we get that. Naive T cells, right? So they bind a little bit. So that's the initial low affinity. Okay, so naive T cells will then migrate into the paracortical areas. Okay, so they've ended up binding to each other. And now naive T cells migrate into the paracortical areas under the influence of a chemokine gradient. Okay, so now these initial binding will now end up getting inside the paracortical areas. This is the paracortical area. So they come I don't see any arteries here though, but anyway, they get into this area somehow. Under the influence of a chemokine gradient. Okay, so they're just feeling around in the dark. Obviously, T cells will go into the paracortical areas, and B cells are guiding along the chemokine gradient into the lymphoid follicles. Right? The thymus to the blood, from blood to, well, here. So you have blood with naive L-selectins, high endothelial formation. Okay, so we'll just copy that and put that there. And if you were a T cell, then you would go here into the paracortical areas. But if you are a B cell, you would go into here. Wait, you would go here. That makes sense to me. All right then. So this migration we're learning about, we know that happens. Okay, so the less is known about the lymphocyte recirculation through the spleen. Now we're talking about the spleen. Okay. So we're done with the lymph nodes. Okay, so let's quickly review, right? So lymph nodes, this is the part of the lymph nodes. So here's a lymph node. You have one area where the lymph is coming in and some other route where the blood is also coming into the lymph node somehow, but doesn't display it here. But anyway, you have through the blood, these lymphocytes, either B cells or T cells, they both have L-selectins, and they both end up binding to the high endothelial venules, adjacents, and they have a low affinity interaction, and then they just kind of feel their way through a chemokine gradient into their respective areas. The B cells will just feel their way into the lymphoid follicles right there, and that's probably the primary follicles. And the T cells will feel their way all the way into the paracortical areas right there. So that's what's happening basically in the lymph node. Okay. So now let's talk about the spleen. And in the spleen, what you have, oops. In the spleen, what you have, let's go down to the spleen. There we have the spleen. Okay, so in the spleen, here's what's happening. This is known about the recirculation through the spleen. Naive T cell, less is known about lymphocyte recirculation through the spleen. Okay, so how do they recirculate? Spleen lymphocyte recirculation. Okay, so what's happening here is you have naive T cells home to the periarteriolar sheaths. Oh, home as in use it as a verb, okay. So anyway, naive T cells, basically that's their home, periarterial lymphoid sheaths, and naive B cells, they end up create lymphoid follicles right outside of the T cell area. Okay. The rate of recirculation of naive lymphocytes through the body by this system is quite high. The rate of recirculation of naive lymphocytes through the body by this system. Which system? The system of lymphocyte recirculation, okay, is quite high. It is estimated that each lymphocyte passes through each lymph node. It is estimated that each lymphocyte passes through each lymph node in the body once a day and through the spleen every 2 days on average. Each lymphocyte. This high rate of trafficking maximizes the possibility that the very small number of cells having a specific antigen receptor have the maximum possibility of encountering that antigen when it is present. That's a bunch of different receptors they have, and you just hope it might bind to something, huh? That's how it works. So we're learning about here is, so we know that the naive T cells home to periarterial lymphoid sheets. And we know that B cells, so once you enter the central arteriole, all the naive T cells will similarly feel their way into the PALS, periarterial lymphoid sheets, and the B cells will go right outside that area. And they will form these lymphoid follicles all around here. And that would be probably the white matter, white pulp, I'm sorry. The rate of recirculation of naive lymphocytes. Now we're just done with the spleen, basically. So we're done talking with the spleen. And so multi-step sequence of interaction between lymphocyte and adhesion molecules. So it's probably using the same selectin molecules, L-selecting on B and T cells and adhesins, addressins on the endothelial cells. So what is the rate of recirculation of the rate of recirculation of any naive lymphocytes, whether they're going to the lymph node or the spleen, is very high. So they're constantly moving around. So they keep leaving the lymph node, the blood, entering these PALs and germinal center, and then they go back into the blood through these little venules and into the main and portal circulation, or through the efferent lymphatics. And, well, actually, probably not efferent lymphatics, some other venule. Okay, so it is estimated that each lymphocyte passes through each lymph node in a body every 1 times a day. 1 per day equals lymph node, and through the spleen, 1 per 2 days in the spleen on average. This high rate of trafficking maximizes the possibility that the very small number of cells having a specific antigen receptor have the maximum possibility of encountering that antigen when it is present. So this is the whole point of this thing. Why we're doing it, because you have a bunch of lymphocytes that are naive with brand new receptors that are specific for some antigen, and we have to figure out if they might bind to something. So it's very random. It's not like the antigen is caught first and then you figure out what kind of receptor will bind to it. It's like you just have a bunch of receptors and see what fits. If the shoe fits, basically, wear it. That's how it is, kind of, I suppose. Interesting. Okay, so that would conclude this, I think. So what are our take-home points here? Our take-home points are that the naive lymphocytes leave the blood through high endothelial venules. And L-selectins are on lymphocytes, B and T lymphocytes. They bind to addressins on HEV. Naive T cells home to the lymph node, paracortex, or the splenic pals. And naive B cells create a corona outside the T cell area. So they just crown that area. Okay, pretty explanatory. Kind of had to think in 3D, but I think I got through it. All right, chapter summary. Mature naive lymphocytes recirculate. So you have mature naive lymphocytes. They recirculate through the peripheral lymphoid organs, obviously the lymph nodes and the spleen, to search for, and hey, we didn't talk about MALT. Hey, come on now. To search for antigen. Lymph nodes are designed to filter antigens from the tissue fluids. Here, basically, lymph enters through the afferent lymphatics and percolates through the outer cortex and the inner medulla before leaving through the efferent lymphatic in the hilus. Now, this lymph is rich in APCs, right? Because T and B cells are not found in tissue, they are found in blood. And APCs would be things such as macrophages, perhaps dendrites, things like that. Dendritic cells, sorry. So the spleen is designed to filter antigens from blood. Blood is the site of T cells and B cells. Blood enters through a single splenic artery, which branches into arterioles that become surrounded by cuffs of lymphocytes. These are the periarteriolar lymphoid sheets. And on top of those are follicles, with follicles and macrophages nearby. So they have follicles, and these follicles are rich in B cells and macrophages. Lymphocytes leave the bloodstream to enter lymph nodes. So these lymphocytes, once the blood gets to the lymph node, they leave this blood and enter the lymph nodes. Perhaps they use their own L-selectins and, well, they said blood has adjacents. They say they use the word high endothelial venules. That's probably it, the high endothelial venules. They're probably using, these are probably also in the lymph nodes and in the spleen. And they're the ones with adjacents. Okay, L-selectins on lymphocytes bind to adjacents on high endothelial venules, and chemokine receptors mediate the homing of the specific cells to specific areas. Okay. T lymphocytes migrate into the lymph node paracortical areas, and B lymphocytes migrate into the lymph node follicles. That makes sense. In the spleen, T lymphocytes are attracted to the periarteriolar lymphoid sheets. B cells entering the spleen form a corona outside the T cell area. Right? Every lymphocyte passes through every lymph node once per day through the spleen once every 2 days. So probably need to make that per 2 days. Okay. All right. That covers that. Let's move on to the questions. Yay. Okay. Oh no, I saw it. Okay. All right, review questions. A lymph node biopsy of a 6-year-old boy shows markedly decreased numbers of lymphocytes in the paracortical areas. So that's what we're talking about, the T cells, right? Analysis of his peripheral blood leukocytes is likely to show normal to elevated numbers of cells expressing surface blank. Okay, so they have very decreased numbers of cells that are found in paracortical areas. So they probably have very low T cells, it sounds like. So analysis of his peripheral blood leukocytes is likely to show normal to elevated numbers of cell expressing surface. So B cells would be more, right? Maybe natural killer cells might be more too. Because we're talking about, leukocyte, that could be any white cell. Any white cell other than T cells. So we basically need to know that it can't be CD8 or CD4 or CD3 because those are only found on T cells. They could be CD19, and I don't know what CD2 is used for. I don't know. But I would definitely go with E. And yeah, I have to figure out what CD2 is for. So let's go take a look at the answer. And the answer says that the correct answer is E. And the paracortex of the lymph node is a T cell dependent. It is a T cell dependent area. If this area is lacking in cellularity, then the patient has a deficiency of T lymphocytes. B lymphocyte numbers could be normal or even elevated. Now, why would they be elevated? I don't know. Normal, I understand. The only B cell marker on this list is CD19. the marker which is used clinically to enumerate the B cells in the body. Now, CD2 is also known as LFA2. This one is an adhesion molecule found on T cells or thymocytes. Anyway, CD2, also known as LFA2, is an adhesion molecule found on T cells, thymocytes, and natural killer cells. Okay, in a person with T cell deficiency, there would be decreased numbers of cells bearing this marker. Okay, so CD2 is found on oh, for crying out loud. CD2 is also known as LFA2. It is an adhesion molecule found on T cells, thymocytes, and natural killer cells. In a person with T cell deficiency, there would be decreased numbers of cells bearing this marker. Because they would be on T cells and thymocytes, but also NK cells. And it is also called as an LFA2. It is an adhesion molecule. Whereas CD3 was a signal transduction molecule, remember? And CD4 and CD8 are where you shake hands. It's a stabilizing, or what is it called? A co-receptor. Right. All right. Whereas CD2 is an adhesion molecule. Okay. CD3 is found on all T cells. Yes. It is also called the pan-T cell marker, because it's on all T cells. In a person with a T cell deficiency, there would be decreased numbers of cells bearing this marker, obviously. CD4 is found on all helper T lymphocytes. Agreed. In a person with a T cell deficiency, there would be decreased numbers of cells bearing this marker. CD8 is found on all cytotoxic T lymphocytes. In a person with T cell deficiency, there would be decreased numbers of cells bearing this marker. So just remember CD8. CD8 is cytotoxic T cells, CD4 helper T cells, CD3 all T cells, CD2 is all versions of T cells and natural killer cells, and there's also called LFA2. And CD19 is on B cells. B cells also have 19, 20, 21. They also have IL alpha and IL beta. Remember? Okay, moving on. A 65-year-old woman was involved in an automobile accident that necessitated the removal of her spleen. Yowza. So she's not going to have very much good immunity. To which of the following pathogens would she have the most increased susceptibility? Well, in this case, it's going to be some kind of a blood pathogen that is cleaned up by T and B cells. So it's got to be a blood pathogen, I suppose. Let's see. We got the human papilloma virus. That is actually found on, what do you call it? It's an epithelial virus, right? Enteroaggregative Escherichia coli. That is found only usually in the GI, very topical areas. Doesn't usually get in the blood. I mean, enteroaggregative. I don't know if that's the one that enters the blood. No, that's enterohemolytic. Yeah, no, this is not it. Then you have Corynebacterium diphtheria. Diphtheria is a respiratory one, so it wouldn't really enter the blood. Then you have Bordetella pertussis, another that's also a bug that is found in respiration. It's not really blood. I'm thinking it's probably Babesia, because that does enter blood. It's almost similar to malaria, I think. So it's probably A. Let's see. A. Is that correct? Yes, it is correct. Woohoo! Yeah. Okay, so let's read up on that a little. Okay, I can't. I'm trying to hide it. Okay, oh, my finger's there. The correct answer is A. The spleen is the secondary lymphoid organ that is responsible for primary. You know what I'm going to do? I'm going to make this go up, and then I'm going to use this thing here, and then I'm going to copy this because it's not letting me copy it elsewhere. It's being very annoying. There we go. Just copy this, Control C. Now we'll put it over here. Hello, where's my cursor? There it is. What I'm going to do is I'm going to hide it. There. That way I don't need to see it. Well, my hand was on it all this time, so anyway. All right, so the correct answer is A. The spleen is the secondary lymphoid organ, I know that is responsible for primary surveillance against bloodborne antigens. I know that. Now, here's something we're learning new. Babesia microti is an intra-erythrocytic parasite of humans. It is transmitted by the same vector tick as Lyme disease, transmitted by Ixodes arthropod. The same vector as the Lyme disease, transmitted as a vector. They are. Which is Ixodes. That is dangerous. And it goes in the blood. Red blood cells and their parasites are filtered by the spleen. So splenectomy is a predisposing factor in the development of serious disease with this parasite, obviously. Let's talk about Protella pertussis. It is a mucosal surface pathogen that attaches to the upper airways. Okay. Although its toxin becomes bloodborne eventually, the organism itself is confined to the respiratory tree. Okay. Toxin, bloodborne. Then we have Corynebacterium diphtheriae. Corynebacterium diphtheriae is a mucosal surface pathogen as well. It attaches to the upper airways. Although its toxin becomes bloodborne, the organism itself is confined to the respiratory tree. Same thing. Enteroaggregative Escherichia coli is an organism that causes diarrhea. Okay. It causes diarrhea. By producing a biofilm, produces a biofilm-like aggregation of organisms on the surface of the colonic mucosa, which impedes absorption. It is not likely to be a bloodborne pathogen. Okay. Then you have the human papillomavirus, choice E, which actually goes ahead producing localized infections in epithelial cells where it is transferred by human to human contact. Or human to fomite contact. That's not nice. Human to human contact. It is not likely to be a bloodborne antigen either. Polio. We will add those to our micronotes eventually. All right, let's go up to the next question. 3. A 4-year-old boy is referred to a specialist for the diagnosis of a possible immunologic problem. Okay, so he might have a 4-year kid. He might have an immunologic problem. Let's send him to a specialist. The child has extremely elevated white blood cells count, really high white blood cells count. Okay, white blood, with profound lymphocytosis. Oh boy, he probably has ALL. A biopsy performed on a cervical lymph node reveals extreme hypocellularity. Hypocellularity in both cortical and paracortical areas. So we're talking a lack of B cells, cortical, and a lack of T cells, paracortical. Absence of which of the following leukocyte surface molecules could result in this clinical picture? Absence of which of the following leukocyte surface molecules? So leukocyte surface molecules, both A, T, and C, they have what? They have L-selectins, remember? Could result in this clinical picture. That's probably it, because they never attach. So if they don't have L-selectins, they would not attach to the addressins on the high endothelial venules, and thus they will not enter the lymph nodes. So, which are absent? They're the leukins, L-selectins. What are the options? Addressins are on high endothelial venules, so that will be it. Chemokines, that's once you're inside, but they're not even in there. Immunoglobulin family cell adhesion molecules. Yeah, but then that would not explain the T cells. And integrins, those are not on lymph nodes. I believe they are in your blood vessels. So L-selectins, E should be the right answer. Let's see. 1, 2, 3. Is E. Yay. Okay. So the correct answer is E. L-selectins are the molecules found on the surfaces of lymphocytes that mediate their binding to high endothelial venules of the lymph node. This is the means by which lymphocytes enter lymph nodes. Without these molecules, oh, so they do say it's the lymph nodes. They do not say it's the spleen. So maybe it doesn't apply to the spleen. They would be unable to leave the blood. Thus, they would rise in the blood to extreme levels and be absent from their appropriate areas in the secondary lymphoid organs. I see. So the kid probably didn't have ALL. So this is something else, some other disease. And I would like to know the name of this disease. Probably L-selectin deficiency or something. Righto. Okay, so let's read the next options. Addressins are the molecules complementary to L-selectins. Let me just hide that. Okay. Addressins are the molecules complementary to L-selectins, which are found on endothelial cells. Right, I agree. Although their absence could also cause similar signs, yes, the questions asked about the leukocyte surface molecule, and addressins are not found on leukocytes, agreed. Chemokines are not cell surface molecules, but do play a role in the homing of lymphocytes to specific regions of the secondary lymphoid organs. An absence of chemokine receptors on leukocytes could have caused similar signs, but chemokines themselves are soluble substances, not surface molecules. An absence of chemokine receptors on leukocytes could have caused similar signs, but they're not soluble substance. I mean, they're soluble, they're not surface. So we're looking for a surface molecule. Okay. So addressins was wrong because it's not leukocyte. Chemokines are wrong because they're not surface molecules. Immunoglobulin family cell adhesion molecules, or IgCAMs. Immunoglobulin family cell adhesion molecules. Are adhesion molecules found on various cells of the immune system. So all those cells of the immune system, they have these IgCAMs, immunoglobulin cell adhesion molecules. They mediate cell-to-cell interactions as well as binding to the extracellular matrix. Their ligands are integrins. If these molecules were absent, cell-to-cell interactions would be diminished, but movement of lymphocytes out of circulation and into secondary lymphoid organs would not be affected. I think these are the ones that allow the neutrophils to enter the tissues. or macrophages? I think it's neutrophils. Okay, so that's important to know. I should probably highlight that because I don't see that. You see that? The adhesion molecules found in various. They're mediate. Okay, so immunoglobulin, cell adhesion molecules are adhesion molecules found on various cells of the immune system. They mediate cell-to-cell interactions as well as binding to the ECM. Their ligands are integrants. If these molecules were absent, cell-to-cell interaction would be diminished, but movement of lymphocytes out of circulation and into the secondary lymphoid organs would not be affected. Integrants, these are the ligands of the IgCAMs, right? They are involved in cell-to-cell interactions as well as binding to the extracellular matrix. If these molecules were absent, cell-to-cell interactions would be diminished, but the movement of lymphocytes out of circulation would not be affected, obviously. Oh no, I saw it. Well, I'm not gonna look at the options. I'm just gonna try to answer without looking at the options. Okay. Question number 4. So, question number 4 talks about a 6-year-old child is taken to his pediatrician because the parents are alarmed about an indurated fluctuant mass on the posterior aspect of his neck. Yowza, I would be too. Indurated, fluctuant. What does that mean? Indurated fluctuant. Mamma mia. Let's see. I'll just look that up real quick. Come on. Oh my gosh, this is really slow. But anyway, indurated means depressed, right? But fluctuant, I guess it keeps changing. That's probably what I mean on the posterior aspect of his neck. Fluctuant mass. It's probably something that becomes indurated but doesn't get indurated. It is movable and compressible. Okay. On the posterior aspect of his neck, the mass is non-tender and shows no signs of it's probably some lymph node. The child is examined carefully and no other masses are found. The pediatrician decides to submit a biopsy of this area to a pathologist. The pathologist reports back that the mass is a lymph node with markedly increased numbers of cells in the cortical area. Cortical area translates to B cells. Okay, so now what? What do you want? What's the question? Fluorescent antisera to which of the cell surface markers is most likely to bind to cells in this area? So so you have some serum to which of the cell surface markers? So we want to know the cell markers on B cells, basically, which would be CD19, 20, 21, Ig alpha, Ig beta, MHC2, MHC1. Yeah, that's about it. So one of those should be my answer. Let's see. Can't be CD2 because we know CD2 is found on T cells and NK cells, and it's also known as LFA2. Can't be 3, 4, what is 16? I don't know. But definitely it's CD19. What was the answer? Was it E? I already forgot. We did 3, we did 4. Yep. Okay, so that's right. Okay. I'm going to go up, pull that up again. Takes me a while to figure out what they're asking. Okay, the correct answer is E. The cortex of the lymph nodes is B lymphocyte area. Thus, cells in this area would stain with fluorescent antibodies against CD19, the molecule that serves as a portion of the B cell signal transduction complex. Indeed, it does. Remember, CD19 signals to CD20. Well, does it go to 20? I don't know. Well, let's say CD19, the molecules that serve as a portion of the B cell signal transduction complex. This molecules would be found on all B cells, but would be absent from T cells, macrophages, and NK cells. Ooh, so I'm curious about the CD16. We'll get to it. It's a T cell marker. T cells will be found in the pericortical areas of the lymph nodes. CD3 is a T cell marker. It is a signal transduction complex of the T cell and will be found in all T cells. T cells will be found in the pericortical areas of the lymph nodes. CD4 is a marker for the helper T cells. These cells will be found in the pericortical areas of the lymph nodes. Here we go. CD16 is the Fc receptor for IgG antibodies. Is it really? CD16 is the Fc receptor for IgG antibodies. So you have an IgG antibody. It has an Fc part. That's the stick, not the two arms of the Y, but the stick. And that's where CD16 binds. Because the other end, right, that's probably the, so it's probably got to do with the macrophages. It would be found on natural killer cells and phagocytic cells, which could be macrophages and neutrophils, which would not be numerous in the cortex. Where would they be? Of the lymph nodes. Phagocytic cells typically are found in the medullary cords. Remember that. They're found in the medullary cords of the lymph nodes. Good to know. Moving on to question number 5. Only 5 questions. Fine. A radioactive tracer dye is injected subcutaneously into the forearm of an experimental subject. Okay, we don't pay for it. Whatever. What is the first area of the what is the first area of the first draining lymph node that would develop significant radioactivity? So what are you asking here? You're asking me, so from the forearm, it's probably the axillary nodes. I don't know. That's where the lymph will drain, and from there to the thoracic. Let me see. What are we asking? A radioactive tracer dye injected subcutaneously into the forearm of an external. Okay, fine. So you have a dye. Where first area of the first draining lymph node. So the first draining lymph nodes are obviously the axillaries, right? What is the first area that would develop significant in that lymph node, where would the radioactivity happen first? So you are basically asking how the lymph is traveling through the lymph node. So we're talking afferent, cortical sinus, and then into the medullary sinus. But before that, you have the B cells in the follicles, and then you have the T cells, right? So that's probably how it's going to happen, from the cortex to the paracortex, right? So, because that's how it drains. So here's the question. Oh, they even gave me subcapsular. Subcapsular sinus happens first, then the primary follicle. These both are part of the cortex. First area, the first draining lymph node that would develop significant radioactivity. So this is lymph. So where is the lymph touching first? Well, it won't be all of cortex, but it definitely would be the subcapsular sinus, because the other one is the medullary sinus. So it's probably subcapsular sinus, because cortex is a big area. And then there's paracortex. I mean, it is the cortex, but if you want to know where in the cortex, it will be primary, but subcapsular sinus happens first. So I think I'd go with subcapsular sinus. Significant radioactivity. We're not talking about a reaction happening. Well, no, okay, maybe we are. We're asking about where they will bind first. So they're not binding in the subcapsular sinus at all. But we are binding in the primary follicle, probably. Oh gosh, am I overthinking this? Is it cortex? Because that's where you'll have the radioactivity, but that's where you're having the first binding taking place. Primary follicle is B cells, paracortex is T cells. So maybe it's not subcapsular sinus, because that means that there's no binding taking place in there, you know, so maybe that will, if there's no binding, then there's no radioactivity. So that's not true. It could happen in the primary follicle. It could now, does it bind them both? I don't know. And primary follicles are found in the cortex. So cortex? I don't know if it's specific to B cells or T cells. See? Oh gosh, it's a big question. I don't know. Okay, so gun to the head. What do you answer? What do you answer? Where is develop significant draining lymph node that would develop significant radioactivity? So what is bigger, maybe? Is that what we're asking? I don't know. I feel like saying primary follicle or cortex. Let's just say cortex because it just kind of covers a big chunk. It covers both primary and, okay, I'm going to say cortex. I don't know. Honestly, I don't know what the question's asking. That's my problem. Okay, 5. Oh my gosh, I was right the first time. Subcapsular sinus. I overthought it, but I want to know why, you know. So let's see, where did I go wrong? Correct answer is E. Lymph nodes are designed to filter tissue fluids. Fluids entering the lymph node do so through afferent lymphatics and are released into subcapsular sinus. Agreed. From there, fluids percolate through the cortex into the medulla through medullary cords, and finally exit through the efferent lymphatics in the ileum. Okay, I knew that. The cortex of the lymph node is directly beneath the subcapsular, sinus. It would be second region of lymph node to be exposed to the radioactive tracer. The cortex is a B lymphocyte rich area. Okay. Capsular cortex, agreed. Okay, the medulla of the lymph node is rich in macrophages. It would not receive radioactive fluid until it had passed through the cortex and the paracortex. The paracortex of the lymph node is in T cell area. It lies between the cortex and the medulla and thus would receive radioactive fluid after the cortical areas. Primary follicles are found in the cortex of the lymph node. These are areas of the active B lymphocyte proliferation. Okay, so cortex of a lymph node is directly beneath the... Why am I getting distracted? Primary follicles are found in the cortex of the lymph node, right? I have to put this in order. Suddenly I'm just shocked that I got it wrong and distracted. Okay, moving. Let's just read this through. So this is the order, right? First thing that happens is lymph nodes. This is the order of things. You have lymph nodes designed to filter fluid. Fluids entering the lymph node do so through the afferent lymphatics, released into the subscapular sinus. From there, fluids percolate through the cortex into the medulla. Well, medullary rock. Into medulla through the medullary cord and exit through afferent lymphatics in the ileum. Okay, so from the cortex of the lymph node is directly between the subcapsular sinus. It will be a second region of the lymph node to be exposed to the radioactive tracer. The paracortex of the lymph node is the T cell area. It lies between the cortex and the medulla and thus will receive radioactive fluid after cortical areas. And then primary follicles are found in the cortex of the lymph node. These are areas of active B lymphocyte proliferation and cloning. They would receive radioactivity after it left the subcapsular sinus. So subcapsular sinus, I have to write this down again. So here's what's going on. Ooh, lost. Here we go. So you have lymph. It goes from afferent lymphatics. They enter subcapsular sinus. From there, it goes into the cortex, where and then medulla and medullary cords, efferent, lymphatics, ileum, which has efferent lymphatics. Okay, so in the cortex, what's happening is directly beneath the substation, it would be the second region to be exposed to the B cortex is B cell rich. Okay, the medulla of the lymph node is rich in macrophages. Okay, it would not receive the radioactive matter that has passed to the cortex and paracortex. Okay. The paracortex of lymph nodes is the T cell area. It lies beneath the cortex and the medulla between them, and thus would receive radiation after the cortical areas. Primary follicles are found in the cortex of the lymph node. Cortex. B cells. These areas of active B cell proliferation and cloning. These are after it had left the subscapsular sinus. So what was my issue? Let me just go ahead. So lymph, efferent lymphatics, subscapular sinus to the cortex. And from the cortex, it goes into the paracortex. From the paracortex, it goes into the medulla. And from the medulla, it goes to, well, I don't know. Are the medullary cords inside? Into the medulla through the medullary cords. Fluids percolate through the cortex into the medulla through the medullary cords. Into the medulla through the medullary cords. It sounds like you're saying medullary cords which enter the medulla full of macrophages. And then it enters the ileum and lymphatics. And where exactly is the fibrous capsule in all this? Well, efferent lymphatics penetrate that, right? So it would probably be here. Lymph is coming scapular outer cortex areas, the cortex. You have the follicles, you have the inner medulla, you have the medullary sinus. Hello. Medullary cords. Where is the medullary sinus exactly? Medullary cords, medulla. Only has medullary sinus in it. Medullary sinus. Ileum efferent, and from that efferent, and from there you end up with the thoracic duct, which will eventually drain into the vena cava, which will enter the heart. The heart, and then it goes through all that jazz. Yay. So why did I get this wrong exactly, right? I got this wrong because I didn't understand the concept that they were asking. They were just simply asking, what does it touch first? Whereas I was saying where the radioactivity would happen first. So am I wrong in assuming that radioactivity actually does happen in subscapular sinus? I suppose when you inject somebody with that and you're looking at the lymph node and then you take the x-ray, a moving x-ray, and you see how it's happening, it would enter there first. So I'm thinking to my concept of radioactivity is wrong here. What I need to know is this radioactive tracer dye lights up throughout. It doesn't need to bind to something to light up. That is the key here. That is what I need to know. Okay, I can understand that now. It lights up all the time. Adhesion molecules, T cell lymphocyte. Okay, I understand then. Great, good to know. Well, with this, I'm just going to end this and start a new chapter.